SAS class with Amanda. Hey! In this video, we're just going to find a confidence interval comparing two means. This is a continuation of our two-sample t procedures, just so that we have an example of how to find a confidence interval. Alright, so we want to find a 90% confidence interval for mu1 minus mu2, and that's because the confidence interval estimates our population parameter. And in this case, our population parameter is mu minus mu2. And remember that the formula is x bar 1 minus x bar 2, because this is our statistic. We're centering at this x bar 1 minus x bar 2 plus minus t star. And then we have this nasty looking formula for our standard deviation. Alright, so we have a lot of this information already, but let's just read this question because it's important to read directions. Giving 90% confidence interval for mu1 minus mu2, the difference in average daily minutes spent standing and walking between lean and mildly obese adults. We choose 20 healthy volunteers who don't exercise, so that's a population 1, I think. Oh, hold on, this is probably written wrong, so let's ignore that. We have 20 healthy volunteers who don't exercise, 10 lean, and 10 mildly obese, but still healthy. So the 10 mildly obese are still healthy. We track their moves for 10 days with sensors and find that x bar 1 is equal to, this is the minutes spent standing and walking, okay, x bar 2, etc., etc. So let's just, it's not well written here, but I gather that population 1 is going to be lean people, and population 2 is going to be mildly obese people. Okay, and we have a sample size from each equaling 10. All right. And we have a mean x bar 1 equals 525.75 minutes with a standard deviation 107.121 minutes. And then here we have an x bar 2, which is equal to 373.269 minutes. And S2, which is equal to 67.498 minutes. All right. And we want to estimate their difference with a 90% confidence. All right, so already from this information, we can look at the degrees of freedom, which is equal to the minimum of n1 minus 1 and n2 minus 1. Which is the minimum between 9 and 9, which is easy for us to figure out. They're both the same number, so it must be 9. All right, and so with this, we can figure out what t star is from the distribution, the t distribution, t of 9. Okay, so going back to our table, which is all marked up from earlier videos, we want to find row 9, which is this one, and we want to look for the column that corresponds to 90%, we see is this column, and so we have t star is equal to 1.833. Okay, so t star is equal to 1.833. And looking at our formula again, let's just verify. We have x bar 1, x bar 2, we have a t star now, we have an s1 squared, an n1, etc. So now we can just plug things into our formula. So we are 90% confident that mu1 minus mu2 is between the values 79.09 minutes to 225.87 minutes. Right, so the difference is between these two values. Since they're both positive values, that implies that mu1 on average is greater than mu2. And it also implies that there might be, so this implies mu1 on average is greater than mu2. And it also implies that there is a statistically significant difference between mu1 and mu2.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so nil, 1/10. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife, the implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.